Is it gonna rain tomorrow? Does it matter? Well, if you're planning on spending all day inside watching Netflix, then probably not. If you're running a civil construction project that's turning over $1 million a day, then a day of stand down due to wet weather is a huge issue. If you've only budgeted for 10 inclement weather days and you're 50% of the way through the project and you've already had 15, then it's a major issue. Uncertainty is unavoidable on construction projects. Everybody knows you need to plan projects. Planning won't separate you as a construction manager. But if you can learn to manage and take accountability for unpredictability and uncertainty, then you're going to put yourself ahead of 99% of construction project managers. So in this video, we're going to outline everything you need to know about construction project risk management. We'll talk about why it matters, what it is, the core concepts, the different types of risks you'll face on a construction project, how to manage risk on a construction project from end to end, how to deal with the specific environmental, health and safety, and cash risks, and finish off with a case study where we explore applying these concepts in practice. So let's start off with an all-important question. Why should you care about risk management? Well, the first thing I want to establish is that planning is the baseline. 98% of project managers create a plan for their project. Yet, only 48% of construction projects finish under budget and ahead of schedule. Why? Well, a plan tells you what should happen, given our assumptions and our planning is correct. But given such a small percentage of projects achieve their objectives, we can see there's a huge difference between the way people plan and the way projects are delivered in practice. So, why do plans fail? Well, for a simple reason, that construction is unpredictable. We get weather conditions we never could have planned for. We get scorching hot days, heavy rains, or strong winds that cancel crane lifts. We get supply chain disruption. We get late delivery from suppliers or key subcontractors going broke. We get site conditions that we couldn't have prepared for. There might be unknown utilities or poor geotechnical conditions that screw up our earthworks productivities. And we get people issues. We get labor shortages or disputes with subcontractors. Every plan we create relies on assumptions around these core variables that always end up being different to what we planned for. On top of that, because the construction industry is so heavily commoditized, meaning the cheapest price tends to win, the subcontractor or contractor who makes the most aggressive assumptions around these unknowns tends to be the ones who get the job, meaning the person who underestimates the risk is often the one doing the project. This leads to a set of circumstances and an environment that makes effective risk management incredibly difficult. You can plan as much as you want, but planning alone won't protect you if your assumptions are wrong and you have not prepared for uncertainty. Excuses like we were late because a key supplier failed just aren't good enough, and the best construction managers accept, prepare for, and deal with uncertainty. They take accountability and ownership of it through effective risk management. And the evidence supports this. A big study by McKinsey found that effective risk management is one of the key drivers of successful project delivery. You can think of it like this. Planning develops a roadmap for how we're going to deliver the project, and risk management protects this roadmap. It involves several key actions, including identifying possible risks, possible sources of uncertainty that matter, assessing their impact and likelihood, developing response plans such as avoiding, reducing, transferring, or accepting, and monitoring and updating this risk management plan continuously. Fundamentally, effective risk management is about resilience, not prediction. You can't predict everything that's going to go wrong, but you can be ready for it. A study by the PMI found that effective risk management can reduce the impact of unpredictable delays by up to 20%. Risk management protects your profit margins, keeps your schedule realistic, reduces costly disputes with subcontractors and suppliers, and enhances safety and compliance. Without it, we'll blow our budgets, miss deadlines, suffer quality issues, and damage the relationship we have with our key clients. Planning tells you what should happen. Risk management prepares you for what might happen. So now we understand why risk management matters and why you need to be able to deal with uncertainty to be an effective construction project management. Let's get into the nuts and bolts of the topic and start by talking about what is risk management. So put simply, Risk management, what is it? Well, it's the process of how we take uncertainty and turn it into manageable action. Risk management is the structured approach of identifying, assessing, treating, and monitoring uncertainty that may affect our project goals. Project goals could be anything like cost, time, quality, scope, safety, reputation with the client. So, risk management is the way we address the sources of uncertainty and how they impact these goals. It allows us to turn uncertainty into manageable action. Okay, intrinsic to this definition of risk is this term uncertainty. So, it's important to distinguish between what's a risk and what's uncertainty. So, all risks are uncertainty, but not all uncertainty are risks. What do I mean by this? There's uncertainty in everything and everywhere and what we do. Who will win the lotto tomorrow? What is the weather going to be like in Greenland? And what will our production rate for trenching be? These are all sources of uncertainty. The difference is that what our production rate for trenching is a risk for the project. A risk is a source of uncertainty that matters. So any risk has to have two components. It needs to be uncertain and it needs to matter, meaning needs to impact the project goals. So risks are specific uncertain events or conditions that could impact the project objectives. Importantly as well is that if something has happened, it's not a risk. If we know our production rate is lower than what we planned for, it's not a risk because it's not uncertainty. It's a known issue we need to deal with. Okay, so next up, we've got this idea of a threat versus an opportunity. So it's important to understand that risks are not always bad. How much is it going to rain tomorrow is a risk. It's a source of uncertainty that matters and it will impact the project objectives, but it could be both a threat, meaning it has a negative impact on the objectives, or it could be an opportunity. If we have a contract signed where we're allowed to claim additional cost and time for any inclement weather, then it would be an opportunity. If we're going to get paid extra to deliver the same project scope because we're delayed by poor weather. If, however, we've got a fixed budget for inclement weather, and if we go over that, we have to wear the costs of that, then by definition, it's a threat because it's going to negatively impact our project objectives. Okay, so the goal of risk management isn't just to deal with the negative consequences, it's also to increase the chance of our opportunities happening. So on one side, we're trying to eliminate or reduce the impact of our threats, but we also want to increase the chances of our opportunities happening. Okay, the next thing I want to talk about is basically defining some of these key terms around risk. So we've got a cause, a risk event, and a consequence. A cause is a condition or trigger that makes the risk possible. For example, extended heavy rain could be a cause of our inclement weather risk. The risk event is the uncertain event itself. For example, the concrete pour being delayed because of the poor weather, and the consequence is the impact on project objectives if it happens. So, for example, if excess heavy rain, the cause, delays our concrete pour, the event, then the consequence would be the project timeline extended by 3 days. Clarifying and understanding these definitions helps you understand a bit more about risk management. Okay, let's look at another example. So we've got a key subcontractor is in financial stress due to underbidding multiple projects. That's the cause. The risk event is the subcontractor going into default in the middle of the project and not being able to finish the work. The consequence is then the immediate need to find a replacement, resulting in increased costs because we would to quickly procure someone from the market, delayed because there'll be a period of time where we need to find the additional subcontractor, and potential legal disputes. That's another example of a risk where we've got the cause, so the subcontractor being in financial stress, the consequence or the risk event, which is the subcontractor going into default, and then the consequence, which is the impact of the additional costs and time to find another subcontractor. Looking at another one, we've got design changes. So the cause, the client's approval was pending with last minute conditions and we didn't get it properly signed off before we needed to start work. The risk event is the approved design may need some sort of redesign due to clashes with the facade layout and the mech, elec, and plumbing. Consequence would be redesign work, additional procurement, additional rework on site, cost overruns, and so on and so forth. So that's another example where we've got the cause was poorly coordinated design where the client didn't sign off in time. The risk event was the approved design may require some sort of changes post IFC, and then the consequence would be additional costs due to the rework. Okay, so now we understand a risk event, a cause, and a consequence. Let's actually talk about the risk management process. What is the process that we follow to increase the chances of our opportunities happening and reduce the chances of our threats? So it's a 4-step process which starts with identifying our risk. We need to systematically find the threats and opportunities of the project. And we can do this using brainstorming, so group brainstorming sessions, lessons learned, or expert impact. So the best source of risks I've always found is people who've delivered similar projects. They have a good understanding of what can go wrong. Once we've identified our risks, the next thing is we need to assess our risks. We need to analyze the likelihood of them occurring and the impact if they do occur. Basically, this is going to help us prioritize what risks actually matter. Where should we be putting our limited time and attention? Step 3 is then we need to plan. So we need to prepare for our responses. So basically, what are we going to do to address each risk? So for our threats, the negative risks, we can avoid them. We could change the plan to remove the risk. We can mitigate them. We could take steps to reduce either the likelihood of the risk occurring or the impact if it does occur. We could transfer this risk to a third party through a subcontract or through insurances. And if they're not significant or not a big impact, we could just accept them and choose to do nothing. For opportunities, we want to exploit them, so take steps to ensure that they happen, enhance them, increase the chance that they're happening or the impact if they do, share them, partner with someone to increase the chances of them happening, and accept them that take advantage if it happens, but not take any steps to increase the likelihood. And then step 4 is the iterative nature of it, where as we go through the project, some risks will eventuate, some will be closed off. We basically want to continually monitor, review, and update our risk register, add new risks if they occur, and update the plan if things change. Okay, next important concept is a risk register. So the risk register is the principal tool that we'll be using throughout the project to track, monitor, and update our risks. This is the source of truth for uncertainty for the project. So a risk register is basically a live log of the identified risks, the causes and consequences, the assessment, so both the assessment of the likelihood and the impact, the treatment actions, what we've decided to do about it, the owner, who on the project team is responsible for the risk, and the status and updates. And basically, it ensures none of our risks are forgotten. We're keeping track of them, and it's clear who's responsible for what. Okay, and the final concept around risk management are risk tolerances. Okay, so a risk appetite is how much overall risk the organization is willing to accept in pursuit of their goals. It's going to depend on a lot of different factors, such as the size of the project, the dollar size, particularly. If it's a huge project and it goes bad, that's going to have a much bigger impact on your organization than if a small project goes bad. But also their risk tolerance. So how much variation from the plan is acceptable before action is needed. These help decide which risk to treat and which to accept. So for example, we could see that a company that's willing to pursue a solar farm engineer, procure, and construct contract where they're taking all the risk of changing material prices, the installation costs, the performance of the plant is a very different risk profile to a small asphalting job. It's done on square meter rates where the organization is not even taking the quantity risk. So you can see different organizations will have significantly different risk appetites and tolerances. Okay, to summarize, risk management is about seeing uncertainty clearly, understanding what could help or hurt your project, and having a plan to handle it so you stay in control, protect profit, and deliver the project successfully, regardless of the uncertain events and conditions that can impact the outcomes. So now we understand some of the core concepts around construction project risk management. Let's talk about the different types of uncertainty. In this section, I really want to broaden your understanding of what a risk is and all the different sources of uncertainty on a project. So let's explore the different types of risks and how to group them. Really want to give you a framework for thinking about all the different types and forms of risks that exist on projects. Okay, so the first groupings is event versus non-event risk. So an event risk is a discrete, identifiable event that might happen. For example, a subcontractor going broke. These are typically what we think of when we think of a risk, a discrete, identifiable event. However, it's not the only source of or type of risk on a project. Non-event risk is variability from our assumptions when no single triggers happen. And these are critical to understand on construction projects because they exist everywhere. For example, our actual concrete placement productivity is lower than expected. Our actual rainfall is much higher than what we thought it would be, or our production rate for trenching is different to what we planned. These sources exist everywhere and they describe all the different assumptions we need to make. Now, we try to improve the accuracy of our assumptions, but at the end of the day, through our estimate, through our schedule, there are assumptions built into these, and these sorts of non-event risks exist everywhere. In the PMBOK, these are called variability risks. So the key takeaway here is to effectively manage our risk, we need to consider what could happen, so a specific event, but we also need to consider what could be different to what we assumed, a non-event risk. Okay, so the next distinction I want to make are between known risks and unknown risks, referred to as black swan events. So a known risk is a risk we could reasonably foresee based on our past project experience or the experts in our team. These are things we can identify and then plan for. If someone's working at heights, we know that there's a potential that they could fall. So that is a risk we need to address. A black swan event, also referred to as an unknown or unknowable risk, are risks that are unexpected, highly unlikely, and beyond normal prediction. For example, the classic that everyone talks about now is COVID-19 shutdowns, where there was a sudden, huge pandemic. It was unprecedented. There was nothing like it before. You can't plan for specific black swan events, but, and this is the important point, is that you can develop project resilience. For example, having contingency funds set aside, having flexible contracts, good communication between our subcontractors, suppliers, and stakeholders, and strong relationships all help to this idea of project resilience. But we're not planning for a specific risk because it's by definition, we can't know it's going to occur. Rather, we have a resilient and flexible approach that we can adapt if some sort of uncertain event or condition occurs. Okay, next, let's talk about some common ways to group risks and the different categories. So these are typically what we think of when we think of different categories of sources of risks. So first up, we've got technical risks. So technical risks are things like incomplete designs, design errors, or incorrect specifications that impact more of the engineering side of the construction. We've got project management risks, so poor planning, unrealistic schedules, scope creep. We've got contractual or commercial risks, such as unclear terms and potential for claims and disputes. Got financial risks, so these are budget overruns, funding delays, or cash flow issues. It's supply chain risks, so this is where we get late materials, we get subcontractors going broke, or price fluctuations between when we negotiated contracts, when we signed it, and when we needed to order the materials. Got construction risks such as productivity shortfalls, equipment breakdowns, and rework. Got external risks such as poor weather, environmental conditions, or regulatory changes. Got stakeholder risks such as client disagreements or community objections. And then we've got health, safety, and environmental risks such as accidents, pollution, or non-compliance fines. We can also group our risks by consequence. So we could have a cost risk, which is a budget overrun, unexpected reworks, claims from subcontractors. You could have schedule risks, so delays, waiting on approvals that delays the schedule, productivity shortfalls. We could have quality risks, such as defects or non-conformances. We could have safety risks, such as injuries or lost time incidents. We could have environmental risks, such as spills, erosions, or regulatory fines. We could have reputation risks. So this is where the client is dissatisfied or we get negative publicity. And then the final way we can categorize our risks is by ranking them in terms of their impact on the project. So the impact on the project, or the potential impact on the project, is going to be a combination of the likelihood, the probability of the risk happening, and the impact if it does occur. This sort of matrix you'll see everywhere on construction projects, and it's a two-dimensional matrix that is where we classify our risks qualitatively based on their impact, so whether they're negligible, minor, moderate, significant, or severe, and the likelihood of where they occur. So very unlikely to very likely. We can see if something's very likely to occur and very severe if it does occur, and that's where we need to be putting our time and attention. When if something's negligible, if it does occur, and very unlikely, then it's not worth our time and effort. So now we've got a good understanding of the different types and categories of risks that exist on construction projects, let's dive deeper into how to specifically manage risk on a project. So the risk management process is a structured, systematic method for dealing with uncertainty on a project. It ensures you spot risks early, understand their importance, have a plan to deal with the important risks, and then monitor and update your risk register continuously, so as the project progresses and things change, you stay on top of the uncertainty that matters. So most international standards, project management bodies, break it down into 4 main steps. Step 1 is to identify risks. Step 2 is to assess the risks. Step 3 is to plan our responses. And then step 4 is to monitor and review and iterate on the risk management process. Okay, so step 1 is to identify risks. What it means. Basically, it's to systematically find and record all the sources of uncertainty, both threats and the opportunities that can impact your project. How do we do this? We brainstorm with the project team. We use checklists and reviews from last projects and lessons learned. We talk to our stakeholders. We review the contract conditions, the design drawings, site reports. And we engage with experts who know what they're doing and have worked on this exact type of project. For example, during planning, the team identifies that the scheduled concrete pours are planned during the region's peak rainy season. They also notice that the supply contract depends on a single steel supply. So they've identified 2 main risks for their project. Heavy rain that may delay the concrete works, which is a threat. A sole steel supplier that may cause delivery bottlenecks, again, a threat. And if potentially an opportunity where the weather is unusually dry, pours could progress faster than planned. Now, this is broken down into event risk, but you could also categorize this as a variability risk, where we've got a set assumption of how much inclement weather we think there's going to be, and that assumption may be lower or higher than what we predicted. Step 2 is we then need to assess the risk. What this means is we need to analyze for each risk how likely is it to happen and how big will the impact be if it does occur. We can do this qualitatively using categories like low, medium, or high, like the risk register and the risk matrix I showed you in the last section. Quantitatively, if we've got good data, we could actually calculate these numbers specifically. For example, we could look at how much it's rained over the last 10 years, how variable that is, how accurate our assumptions can be, and then we rank our risks. So basically, the high impact, the high probability risks are the ones we focus on. So for example, the risk rain delays, the likelihood's high, and the impact is medium to high. It could push our schedule up 5 days. We prioritize this as high. Our steel supply delay, the likelihood is medium. The impact is high. So then we rank the risk high. And dry weather that speeds up the pours, let's say the likelihood's poor because we've looked at 10 years of historic weather data and it never rains less than what they think it's going to rain. The impact is medium. You only get minor cost savings. So the priority is therefore low. Okay, so then step 3 is to plan our responses. What this means is we decide what action to take for each of our risks. So for our threat, our options are to avoid the threat, mitigate the threat, transfer it to another party, or just accept it. For our opportunities, we can exploit them, enhance them, share them, or accept them. How do we do this? Again, we use brainstorming, looking at all the different practical applications. We assign an owner to each. Again, this is critical because we have to treat risks and risk responses in the same way that we would treat any task in the project. Someone needs to be responsible for it happening. And then we update our plans, our budgets, or contracts if required. So, for example, rain delay. We've categorized as a high risk, so we're choosing to mitigate it using faster concrete curing concrete mix, installing temporary weather shelters where it's possible, and sequencing the pours to allow flexibility. The owner of this risk is the site manager. The steel supply delay, we want to transfer and mitigate this. We want to add in a backup steel supplier to the contract and order the critical sections of steel earlier. So we're both mitigating the risk and then transferring it to a supplier. The owner will be the procurement manager to ensure that's how the supply contract with the steel supply is written. And then for the dry weather opportunity, we want to enhance it basically by just having a contingency crew available that if we get particularly good weather, we can bring in extra resources and we can finish the works as quickly as possible. The owner is going to be the project scheduler. Then step 4, we've got our continuous iterative process, basically just monitoring and reviewing the risks and keeping them up to date. What this means is we keep track of the risks throughout the project. We ask ourselves, are our treatments working? Has a risk changed? And are new risks appearing that we need to assess and identify and plan responses to? Basically, how we do it is we'd set a weekly or monthly catch-up meeting depending on the duration of the project and how important the risks are. And we'd just go through the risk register. We'd go through every risk and look at all the information in it and ask ourselves if it's still relevant. We also want to hold regular meetings to brainstorm and identify any new risks that are cropping up. So, for example, our construction manager monitors the weekly weather forecast and plans the concrete pours around when it's likely not to rain. The procurement manager tracks the steel supply deliveries to ensure the supplier is on track. And if there's delays to the main steel supplier, they get their backup supplier ready. So it's basically just the process of checking our responses working, things changing, can we close off risks, and so on and so forth. Okay, so why does this 4-step approach work? Well, it ensures we start early. The earlier we identify the risks, the cheaper and easier it is to manage them. It's a consistent concept in construction management that the earlier we address an issue, it's generally much cheaper to fix. We assign clear owners. We treat risks like any other task in the project and we assign someone to manage them. We keep it live because this is an iterative approach and we're going through it and continually updating it. We track it and manage it as the project progresses. And we also communicate effectively. We share our risk updates with our client and key stakeholders. So we ensure there's no surprises and we keep them on board and supportive of the project. If something changes outside of our control, at least we can say we had a plan and did our very best. How do you manage risk on a construction project? Working on a project, it's not a question of if risks will eventuate. It's a question of when they'll eventuate and how prepared we are to deal with the projects that implement risk response strategies are 58% more likely to finish on time and 43% more likely to finish under budget. As a construction project manager, if you can master project risk management, it is an undisputable fact that your projects will be more successfully and ultimately your career will be more successful. That's why in this video, we're going to look specifically at risks on construction projects, how to manage risk, the process to follow, how to use risk management to become a better construction manager. Risk is the uncertainty that matters to the projects. It's the things we don't know about, the uncertainty in our plan, and the uncertainty that can impact the outcomes of the project. So when we say risk matters, we're saying risk has an impact on the objectives of the project. What are these? So it could impact the health and safety of anybody working on the project, the impact to the environment, could have an impact on our cost, our budget, could have an impact on the time it takes to complete the project, and could also have an impact on the perception of the project from our stakeholders. When talking about risk on construction projects, we can group these impacts into 2 separate categories. We've got our zero harm goal and we've got our project success goal. So when we're talking about zero harm, we're talking about eliminating any harm to people or the environment. Now, this is an ethical responsibility. It's not about making more money. It's not about making people happy with delivering the project. It's about keeping people safe and avoiding any sort of environmental harm. So this is an ethical responsibility that we have as construction project managers. On the other side, we've got our project success factors. So we want to make sure the project is a success financially and also finishes on time. So when we're talking about project risk management, talking about the process of conducting risk management planning, identification, analysis, response planning, and control on a project. What does this mean in practice? Well, it means we're increasing the likelihood of positive events by exploiting opportunities and decreasing the likelihood of negative events by eliminating threats. Okay, so now we've established what project risk management is in the context of construction projects. Let's go on to talking about the different categories of project risks. So when we're talking about risk categories, we're talking about the categories or the groupings of uncertainty that impact objectives. On construction projects, we've got the following categories of risks. We've got technical risks, construction risks, health and safety risks, environmental risks, commercial risks, and external risks. Okay, so the first one are our technical risks. What are these? These are risks to do with the development of the project technical solution. So making sure that what we build can work and operate correctly. So for example, this might be something like designing the strength of a building foundation to meet the earthquake requirements, or designing a HVAC system to ensure it meets the climate control objectives of the building. Okay, once we've developed the technical solution to the project, construction is the process we go through to create the design, to deliver the project in accordance with the drawings and specifications. There's a lot of uncertainty in this process. We can have issues with coordinating subcontractors, we can have delays in materials, or we can have poor workmanship resulting in defects and rework. So construction risks are uncertainties in the construction process that can impact the objectives of the project. Throughout the construction process, we have the risk of harming workers or members of the public while completing the construction activities. Construction projects are dangerous. We might have to work at heights. We'll be completing crane lifts. We could drop things. We could strike in-ground services while excavating. There's a lot of uncertainties throughout the construction process that can have a significant impact on people's health and safety. And in the same way that we can have health and safety risks, we can also have environmental risks. So we could have an oil spill. We could have polluted water running off into a waterway. We could remove native protected vegetation without the appropriate approvals. So we could have all sorts of environmental risks while we're completing the construction project. Now, tied into all of these other risks, we can also have commercial risks. So these are risks arising from our contractual rights and obligations. So we could have a dispute with our client. We could have a dispute with our subcontractors. Our client could be delayed in paying us, resulting in cash flow issues, or we could be late in finishing the project and incur liquidated damages. In the final category, we've got external risks. So we could have risks arising from our stakeholders or impacted third parties. So we could be prevented in accessing the work site because we have to go through private property, or we could have a utility not giving us approval to complete construction excavation near their underground service. So we can have our works impacted by the actions of third parties. Okay, so we've established what project risk management is and how it relates to construction projects. And we've also spoken about the different categories of risks on construction projects. Let's now talk about the risk management process in construction. Okay, so here we've got an overview of the risk management process. So high level, the risk management process we follow is we establish the context, we understand what's important to the project, we identify our risk and opportunities, then we analyze, evaluate, and treat them. And then throughout this entire process, we're continually monitoring and controlling to ensure the risk management process is working as planned. And we're also communicating with our stakeholders, those impacted by the project, so they're aware of the uncertainty that matters to the project. Okay, so first off, we need to establish the context. What do we mean by saying establish the context? Well, we want to tailor the depth and complexity of the risk responses to the specific characteristics of the project we're working on. There's a cost associated with the risk management process. It takes people's time, it takes resources, that costs money. On top of this, there's a law of diminishing returns. The more effort we put in won't necessarily result in better outcomes. We want to tailor the risk management process to the specifics, project risks, the project specifics. On top of that, we want to understand our specific project risk thresholds. If we're working on a $10 billion project, a $2,000 cost blowout on a material order isn't a big deal. If we're working on a $20,000 minor home renovation, then a $2,000 cost blowout is a pretty big deal. That's why for any specific project we're working on, we need to understand our risk thresholds. What are considered important risks? What are considered unimportant risks? We can group these into 3 categories: safety, schedule, and cost. And for our specific project, depending on the size, nature of the project, we want to come up with a scale of low, medium, and high for the specific project risks. Okay, so we're talking schedule. We could say for our project, a delay of 0 to 5 days is considered below risk. A delay of greater than 20 days is high risk. We can do the same with our cost to come up with different categories of impacts. Okay, so once we've established the context, we understand the specific project thresholds, the context with which we're going to apply the risk management process. The next thing we need to do is we need to identify the risk. We need to identify the sources of uncertainty that matter to the project. It's critically important when we're identifying risks that we're identifying risks. We're not identifying causes, we're not identifying impacts, and we're not identifying problems or issues. When we define a risk, for any risk, we should be able to express it in the following sentence. As a result of a specific cause, an uncertain event may occur which would lead to an effect on objectives. As an example of this, we've got, as a result of latent site conditions, excess contaminated soil disposal may occur which would lead to increased disposal costs. So we've got the cause, which is latent site conditions. We've got the risk, which is excess disposal of contaminated soil. And we've got the impact, additional disposal costs. So how do we identify these sources of uncertainty that matter? Well, there's 3 ways we can do this. We can look at the past, so what has happened on previous projects to give us an indication of what risks may eventuate in our project. We can look at present. We can talk about what we're currently exposed to. We can talk about the future. What could go wrong? We could use brainstorming. So using these 3 broad buckets of past, present, and future, some techniques we can use that integrate these. So we can look at lessons learned from previous projects. We can talk to subject matter experts, so people who've got experience delivering the type of project we're working on. We can use checklists, so a checklist would capture a superset of possible risks we're exposed to on the project. We can look at contract analysis, so we can look at the specific contract we've signed and look at what risks we're exposed to in the contract. We can look at other sources of documents that might give us an indication as the potential sources of uncertainty, and we can use brainstorming. Yeah, the output of the identify risk process is going to be the risk register. This is where we document all of the different types of project risks we're exposed to. So for example, the excess contaminated soil, the design solution failing to meet the client requirements, or additional scope that we haven't budgeted for. We'll categorize these risks, we'll describe these risks, and we'll talk about the effect. Then we need to analyze these risks. So we've identified all the sources of uncertainty that matter. Now we need to analyze them. We need to work out which of these risks matter. Now, there's 2 ways we can do this. We can use a qualitative risk assessment, or we can use a quantitative risk assessment. So qualitative risk assessment is a subjective risk assessment where likelihood and impact are categorized using our risk threshold, so low, medium, or high. Quantitative risk assessment is where we use verifiable data to assign a specific numerical cost or delay to each of the risks. Okay, to complete a qualitative risk assessment, we go through each risk in our risk register and we give it a probability and an impact. So a probability is a chance of occurring. An impact is the result if it does occur. So this can be in terms of how much it will cost if it eventuates, how much it'll delay us, or what sort of health and safety consequence we'll get. Across these two dimensions, we'll categorize these into our risk thresholds and then give it a risk rating. So the risk rating is the product of the probability and the impact. This means high probability, high impact risks will be given the greatest score, with low probability and low impact risks given a lower score. Then each of our risks we can score based on these two underlying characteristics, how likely they are to occur and what happens if they do occur. So a risk that's almost certain to happen and catastrophic if it does occur would be an extreme risk. A risk that is unlikely to occur and low impact if it does occur would be a low risk. Now, this is an important exercise to do because it allows us to get a holistic view of which are the most important risks to the project. Where should we be putting our time and attention? We're going to summarize all this information in our risk register. So against each of the individual risks for the project, we've given it an impact level, a probability level, and then we can give it an overall risk rating. Okay, so we've spoken about how to do a qualitative risk assessment, which ultimately comes down to some sort of subjective judgment as to the impact and likelihood of each of the risks. The other way we can do this is with a quantitative risk analysis. So we can look at all the risks in our schedule and we can assign a numerical value to each of them using data to support us. So we can do this at the micro level, where we look at an individual risk and score that risk based on an underlying calculation. Or we can look at a macro level, where we look at the overall impact of risk on the project outcome. So we do this in terms of schedule calculation or a budget calculation. So the benefits of a quantitative risk analysis is it actually gives us a specific probability of achieving each of the specific project objectives. So we can develop what's referred to as a P50 schedule. So an anticipated finish date based on a 50% likelihood. It also allows us to identify realistic project targets and give us exact values for different project risks, and to also help us analyze the cost of risk responses versus the benefits. Okay, so now we've analyzed our risks. What do we have to do next? We need to evaluate which are the most significant and important risks on the project, and then we need to do something about them. So the important risks, we'll choose to develop a treatment. In response to a risk, there's several different things we can do. We can do nothing. We can ignore it. If it's small, it's insignificant, we choose to do nothing. We can treat the risk, so we can come up with some sort of plan to mitigate the risk. So this means reducing its likelihood or reducing its impact if it does occur. We can undertake further analysis and investigation. Maybe we decide we don't have enough information to perform a proper judgment or proper significance analysis. If we've already got some controls in place, we can simply maintain the existing controls. Or in certain circumstances, we can actually reconsider the objectives of the project. So we can change what we're choosing to focus on and how we're defining project success. So a risk treatment is taking some form of action in response to the risk to reduce the threat or maximize the opportunity. This is the essence of project risk management. If we're not treating our risk, if we're not doing anything about them, none of what we've done so far matters. Okay, so what treatments do we have available for any risk? Or we can avoid or exploit the risk. This means eliminate the risk or make the opportunity definitely happen. We can transfer it or share it with another party. So we can involve another person or party in the risk. For example, if we're exposed to inclement weather, we could transfer this to our subcontractor. We can reduce or enhance the risk, so reduce the threat or enhance the opportunity. Or we can accept the risk. We can just accept the risk as it is and choose to do nothing about it. So what's the optimal strategy? The optimal strategy is going to depend on the specific risk, its likelihood and impact, its risk rating, its urgency, so how quickly we need to do something about it, its manageability, what can we actually do about it, and its propinquity, which is a fancy way of saying how in control are we of the risk, and also the cost of the risk response. Okay, there's a continual problem the project managers have where they make plans, they work out what to do, and they never do it. And it's highlighted by this age-old riddle. If there's 5 frogs on a log and one of them decides to get off, how many are left on the log? Well, the answer is 5. One of them decided to get off, but they didn't get off. Project risk management is worthless if we don't do anything about it, if we don't implement the risk response strategies we've come up with. This goes for any project management process where we develop a plan, we decide what to do. If we don't actually do it, then all the planning we've done has no value. To get anything out of this process, we need to implement our risk responses. The best way to do this is just to treat them as project tasks. Define the scope of the task, the duration, the budget, the completion criteria, and give them an action owner. Allocate the responsibility of implementing the risk response to an individual on the project team and follow up to make sure they do it. Okay, let's talk about our contaminated soil risk. So we're responsible for dealing with contaminated soil in our project, but we don't know how much contaminated soil there is. So what do we decide to do? We decide to manage the risk. We want to transfer this responsibility to a subcontractor. The timeline for implementing this risk response is the procurement phase. So by the time we sign the contract with our subcontractor, we need to have agreed on a way of transferring this risk to them. We've got a budget of $30,000. So we've got contingency funds of $30,000 set aside. And the responsible person for ensuring this happens is the earthworks package lead. So the one preparing and managing the procurement of the earthworks contractor. To successfully implement any project risk response, it's all about having a controlled response. We just need to treat the risk response strategy as any other project task. This means we need a clear plan of how it will be implemented. We need a known deadline for implementing it. We need to reassess the plan if it's not being followed to understand why. We need a budget and a duration. We need a responsible person. And then if we're not successfully implementing the plan, we need to go through a change management process. The essence of risk response implementation is just treating it like any other project task. Throughout this entire process, we want to be monitoring and controlling the process to making sure everything's being followed correctly. We're following up and we're identifying any new risks as they arise. Risk management is an iterative process. We're going to be cycling continually through this process throughout the duration of the project. There's lots of different ways we can do this. We can do process reviews. We can make sure we're regularly iterating through the process. We're following through meetings. We can audit our policies and procedures. We can deal with changes as they arise and assess these in terms of their risk. We can look at outcomes of the project and identify certain trends, like areas where we're overspending the budget. We can look at specific incidents, and we can also communicate and engage with our stakeholders. The key is when we're talking about monitoring, controlling risk management is just to iterate through the risk process, iterate through the entire risk management process. We constantly want to be cycling through identifying, analyzing, evaluating, treating, and then assessing how effectively these treatments are working. Simplest way is to set a regular meeting in your calendar, whether it's weekly, fortnightly, monthly, and identify and treat any emerging risks and look at the current status of our existing risks. In summary, risk is the uncertainty that matters to the project. Risk management is the process we go through to eliminate threats and exploit opportunities. It's a series of steps we follow both at the beginning of the project and iteratively throughout the project. And risk is a reality of projects. It's not a question of if a risk will eventuate, it's when and how prepared we are to deal with it. As construction project managers, we have an ethical responsibility to ensure the safety of everybody working on our projects. Other project outcomes like cost or time are an important part of our jobs, but safety is different. Making sure nobody gets hurt will always be our number one priority. If we can't do it safely, we don't do it. It's as simple as that. That's why in this video, I'm going to talk about how to manage health, safety, and environmental risks on construction projects. I'll talk about what a health and safety risk is, why they matter, and how to manage them. I want to start with a simple example. Looking at the picture on screen, what hazards can you see? Even in this picture, there's a surprising amount of hazards. There's traffic. You could have someone crash into the construction site. There could be underground services like gas or electricity that we dig through. There could be people working around the excavator, leading to people and plant interactions. You could have dropped objects from people working above. You could have a structure collapse. You could have machinery fail. You could have tricks with all the objects on the ground, or you could have an oil spill that goes down the drain. In any construction project, there is a huge amount of different hazards that we need to be aware of and we need to manage. With all these different hazards, as construction managers, our role, our responsibility is to make sure the activity is safe enough to do, that we can be confident that nobody's going to get hurt while doing it. That's where the ethical responsibility of construction management comes in. Okay, so let's define health and safety risk management. So health and safety risk management is the process of managing construction activities to eliminate or minimize, as far as reasonably possible, the risk of injuries or fatalities. So an example of this would be working at heights. Would be using scaffolding and a harness so we can safely complete any works at heights. Another example could be temporary electrical equipment we have set up around the construction site. So we could use routine inspections by a qualified electrician to ensure that there's going to be no electrical faults and the equipment is continually safe to use. And more generally, we could have regular toolbox talks with the workers to make sure they're aware of the different risks on site and they're constantly paying attention to and focusing on safety. Now, managing all of these separate hazards, all of these separate risks is the fundamental ethical responsibility of a construction manager. What I mean by this is while managing cost, managing schedule, it's fundamental to your job role. And if your project's below their budgets, then you're not going to be able to work as a construction manager for long. It's still a part of your job role. Health and safety is different. Health and safety is an ethical responsibility. You're morally obliged to make sure that the people working on the project are safe. The fundamental principle behind health and safety risk management is if the job can't be done safely, then we don't do it. It's as simple as that. The key thing we need to understand, though, is how do we know if a job can be done safely? What does that mean? Well, it means that the hazards have appropriate controls in place. Again, we come back to this word appropriate or sufficient. What does this actually mean? Well, now I'm going to explain a concept called the engineering hierarchy of controls. We're going to clearly define what we mean by an appropriate control. What is a sufficient level of control? So we're going to talk about all of the different controls that we can have in place, going from eliminating a hazard, substituting, isolating, to administrative controls, to simply PPE. We're going to talk about them in terms of their effectiveness, and then what is a sufficient control to have in place. So the first level of control we can have is an elimination control. An elimination control is it's the best. It means we're physically removing the hazard. It means the hazard no longer exists. We've removed the hazard completely. And these sorts of controls are best or easiest to put in place during the planning and design phase of the project, where we have most control over the sequencing and the specific task we need to complete. An example of this, say we've got some works at height. We could say fitting off an antenna on a structure. If there was a way we could fit off the antenna at ground level and then simply erect the structure, then we've eliminated the need to work at height. The next type of control we can have is a substitution control. So this is where the hazard still exists to some degree, but we've substituted it with a safer option. For example, excavating around surfaces, we could substitute mechanical excavation with an excavator, with vacuum excavation with a non-destructive digging truck. The next is an isolation control. So an isolation control is where we physically isolate people from the hazard. For example, if we've got people that need to walk along a road to get to a construction site and there's a risk that they get hit by a car, we could physically isolate them from the hazard by putting in place concrete barriers that protect them. Then we have an engineering control. So an engineering control is where we put in place a system to engineer out the risk. For example, for working at heights, we could put in scaffolding. So that would be an engineered solution to minimize the risk of somebody falling off an exposed edge. Then we've got an administrative control. So this is where we put in place a rule or tell people that they aren't allowed to do something dangerous. For example, we put in place cones along a road and we say people aren't allowed to step across this line to eliminate the risk of interacting or getting hit by a car. And then we've got PPE, so personal protective equipment, which is the lowest level of control we can have in our hierarchy of controls. And it's simply wearing protective equipment like helmets, gloves, high vis, and glasses. And it's the least effective form of control. Okay, so we can clearly define what is a sufficient level of control based on this hierarchy of controls. For any activity where we're exposed to a hazard, we need to have, as a minimum, an engineering control. We can't have an administrative control and a PPE to eliminate the hazard. So we can't say that example of people having to walk along a road to get to the construction site. It's not sufficient to simply say you're not allowed to walk within 2 meters of the road. You have to put in some sort of barricading to isolate or engineer out the hazard. For example, working at heights, if you have an exposed edge, you can't simply tell people you're not allowed to walk up to the edge. You need to put in place some sort of scaffolding that eliminates and or engineers out the hazard. So as a bare minimum, what is safe enough? Well, safe enough means we've put in, as a minimum, an engineering control. So this could be guards on a machine, it could be ventilation in confined spaces, or it could be edge protection when working at height. Simply putting in PPE or administrative controls is not sufficient. So saying you can't go next to an exposed edge or wearing a helmet will protect you from dropped objects, it's simply insufficient and it's not considered safe. Okay, so now I'm going to talk about what tools we have available to manage safety on a construction site. Okay, so the first tool we've got available is a safe work method statement, or a SWMS. So a SWMS is a document used to identify and control all of the hazards. So we walk through a construction activity, look at all the steps in the process, and against each of these steps, we identify the hazards and the control we're going to put in place. Okay, so as an example, we've got a safe work method statement. So a safe work method statement is a table like the one on screen, and it's going to list out what are the tasks involved, what are the hazards associated with the task, and then what are the control measures we're putting in place, and importantly, who is responsible for putting in place the control measures. So if we look at an example, an activity like roof tiling, the hazard is slipping or falling from the roof. The control measure will be scaffolding. Then we specifically document how the control measure will be implemented. So scaffolding, guardrail, and access to the roof. And then who is responsible for it? The roof tiling supervisor. Okay, so the next tool we have available, a safety in design workshop. So safety in design is a series of workshops held during the planning and design phase of a project where different team members throughout the entire life cycle of the project, so during construction, commissioning, operations, and maintenance, all come together and we run these workshops to identify all of the potential hazards across the different phases of the life cycle. These comments are recorded in a register called the Safety and Design Register, and these comments need to be closed out during the design phase. So all of these potential hazards need to be addressed. Now, safety in design is so effective because of an underlying principle. Principle is that the earlier on you identify and control a hazard, the more effective it is to implement the control. So during the concept and the design phase, if we identify a hazard, we can design out the hazard. We can completely eliminate it. If we have identified during the procurement phase, we can make some changes, but we've lost some abilities to influence the design. If we only identify the hazard during construction, we're limited in what we can do. So the earlier we identify hazards, the more control, the more options, the better options we have to control them. Okay, so let's look at a safety in design example. So we've got A hazard that's been identified, which is working at heights, which is roof access for services during maintenance. There's no existing controls in place. The phase of the project is the operations phase, and then we also put in the likelihood and consequences and the control method. So a control method is to include safe maintenance access points and facilities for harnesses in the design. And then we've got our control, the level of risk after the control is put in place. We do this for all the potential hazards identified during the safety and design. Next option we have available is competency and training. So we can train the people completing the task who have the skills and capabilities to complete them safely. So there's two parts to this. There's verifying competencies. For example, if we're getting someone to do electrical work, we need to check they're an electrician. The other way we can do this is we can actually train people and equip them with the skills to complete the task safely. For example, we can do a site induction so the workers are aware of the specific hazards to our site. Now, I've stressed the importance of safety as an ethical responsibility. I want to highlight another important consideration, that safety is a legislative requirement. It's an ethical responsibility, but it's also a legal responsibility. It's a criminal offense to have people working in unsafe conditions. As a construction manager, you can go to jail if you don't properly manage and control safety on projects. And ultimately, one of the most important things with safety is to develop a culture of awareness, to make sure safety is at the forefront of everybody's mind, that we're regularly discussing it in pre-starts, toolbox, and site inspections, and people feel they have the authority and capability to stop work if they feel unsafe. Okay, so what are the key takeaways? Well, safety is an ethical responsibility. It's not a bureaucratic activity. It's an ethical responsibility we have to make sure the people doing the work can go home safely. We can't do something safely. We don't do it at all. What is safe enough? Well, safe enough means that based on our hierarchy of controls, we have, as a minimum, an engineering control in place for any hazards. And there's a variety of tools we've discussed available to us, including safe work method statements, safety and design, toolbox talks, to ensure these controls are in place and we can fulfill our ethical responsibilities. In this video, we're going to go through a case study of effective project risk management. Often the best way to learn is through examples. We're going to cover everything we've spoken about so far in this section. We're going to go through and we're going to apply it to a wind farm. Okay, so the project we're working on is the construction of a new wind farm. It's in a coastal area with high wind potential, and the objective of the project is to generate electricity and connect to the local power grid. Okay, so let's recap our risk management process and how we're going to control the uncertainty that matters on our project. We need to establish the context. We need to identify the risks and the opportunities. We need to analyze these risks, we need to evaluate them, and then we need to treat them. Okay, so step one, we need to establish the context. So we've got an overview of the project, the construction of a wind farm in a remote coastal area to generate renewable energy. The goal of the project is the timely installation and activation of turbines to meet energy production targets and capitalize on favorable weather conditions. Stakeholders we've got the project owner, the contractor, logistics providers, local authorities and environmental agencies, and the constraints. So we've got challenges include complex logistical issues, weather variability, and environmental compliance. Okay, so as part of properly establishing the context, we need to go through and determine the impact and likelihood of different risks and categorize them into low, medium, and high. The next step is we need to identify our risks. So we can do this through stakeholder engagement. So conduct interviews with key project workers, stakeholders such as the logistics providers and the regulatory authorities, host risk workshops, and then review our existing documentation such as the EPC contract, the project specifications, the grid connection requirements, and any specific environmental approvals. Okay, so the risks we've identified. Weather interruptions, so high winds can cause disruptions to things like crane lifts. We've got supply chain delays, so delays in having the turbines delivered. Transportation challenges, so difficulties in moving the oversized turbines to site. technical failures, so risk of malfunction and underperformance of the turbines, and environmental compliance, so challenges in adhering to wildlife and environmental regulation. Okay, so now we're going to analyze and focus on one specific risk, the transportation challenges. So delays or issues to transporting the large turbines to the site. Challenge on any wind farm because of how big the turbines are. And it's such a challenge to an extent that you have to upgrade roads often. So the likelihood this is high due to the remote location and the complexity of the route. The impact could significantly disrupt the critical path tasks like delivering the turbines to site, and we're rating the risk as critical. So it's highly likely to happen, and it has a huge impact if it does happen. Okay, so now we need to evaluate the risk. So we assess each risk based on the impact to the schedule, budget, stakeholder expectations, and safety, and we want to prioritize the key most important risks. So these ones we've identified are transportation challenges, weather interruptions, and supply chain delays. These are our critical risks that we need to focus on and that we need to do something to address. Okay, so for the transportation challenges, what are we going to do about it? Okay, so we need to get route planning and permit approvals. So we create this as a project task and we allocate that responsibility to someone. We should engage a specialist transport providers. We want to engage a company that has done this exact type of work before and can coach us through the entire process. We want to set up a local staging area to make the trip as easy as possible. We want to consider weather when we're doing this. So all of these possible risk responses are our risk and opportunity treatments. We need to treat as project tasks. We need to make them the responsibility of somebody to implement. Once we've decided to implement these specific risk response strategies, we then need to monitor how effectively we're managing the project risk. So we're going to use real-time tracking. We're going to use GPS and regular check-ins on each of our deliveries to make sure that they're progressing as planned. We're going to have regular risk review meetings, so once a week, once a month. We're going to have a workshop to reevaluate the risks, and we'll determine how effective our response strategies are. And we're going to maintain our contingency and adjust it as we proceed through the project. So in summary, we worked through a simple case study of a wind farm construction project to look at the types of risks and what we could do about it. As you can see, proactive planning is a form of effective risk management. If we put in the upfront effort to think about everything can go wrong, what is the uncertainty that matters, what can we do about it, and then treat the risk management as project tasks, as specific activities allocated to someone. We put them into place and we focus on what we can control. We'll do a lot to deal with the inherent uncertainty of any project.